So good afternoon, good morning. First year BSc Data Science Statistics class. So today we discuss about frequency distributions and their graphs, various types of frequency distributions methods like that. So frequency distribution. A frequency distribution is a table that shows classes or intervals of data with a count of the number in each class. The frequency f of a class is the number of data points in the class. So generally the given data is divided into or taken into various classes by taking various considerations like taking minimum value of the data, maximum value of the data, range and mid value, class interval, like that. So the given data is divided into classes. So in this example we may take some numbers, and the numbers are the minimum value of the number is 1 and the maximum value is some 20. Here we may take the classes divided into, the numbers are divided into classes by taking 1 to 4, 5 to 8, 9 to 12, 13 to 16, 17 to 18, like that. So in the left hand side it is called as lower limit, and upper right hand side it is called as maximum limit or maximum limit. So in that class we may count all the numbers, taken into consideration, and count all the numbers according to this class range or distribution. So in this diagram we may use class and frequency f. What is frequency? Frequency means number of data items which are in that class interval, which are held in that class interval. So in the class interval 1 to 4 there are 4 numbers are there. Into 1 to 5 class there are 5 intervals are there, like that. So it is a class and frequency. So we may take some example and we may calculate all these things. So the class width, what is the class width? The class width is the distance between the lower or upper limits of the consecutive classes. So what is the class width? Generally class width is the difference between the maximum and minimum number of a class. So 5 minus 1 it is 4, 9 minus 5 is 4, and 13 minus 4 9, that is 4, like that. So the class width is 4, and frequency means the number of items. What is the frequency? The frequency is the number of items, data items fall in that class. So the range is the difference between the maximum and minimum data entries. What is the range? Range is generally the difference between the maximum and minimum data entries in a given set of numbers is called as the range. So how to construct class frequency diagrams, or how to construct frequency distribution diagrams, tables, by using some sample data. So there are some steps to be followed. The first one is decide on the number of classes to include. The number of classes should be between 5 and 20, otherwise it may be difficult to detect any pattern. So first of all, after giving some sample data, after taking some sample data, first step you have to decide how many classes are taken, or how many classes should be taken, or class interval should be taken. Generally the class intervals are generally taken at in between 5 and 20. So next step is find the class width as follows. Determine the range of the data, divide the range by the number of classes, and round up to the next convenient number. So here we are using some various number of tens, like class interval, range, and class width. What is the range? Range is, what is the range? Range means generally maximum number of the data item minus minimum number of the data item by number of class items. That is called as range. So what is the range? range is equals to maximum value of the data minus minimum value of the data by number of class intervals taken. That value should be rounded into the nearest integer. That is called as a range. So in the next step, find the class limits. You can use the minimum entry as the lower limit of the class, first class, to find the remaining lower limits. Add the class width to the lower limit of the preceding class. Next is make a tally marker for each data entry in the row of the appropriate class and count the tally marks to find the total frequency f for each class. So this is the example. So this is the example program or example for how to calculate, how to take, how to determine class intervals, range, class widths and frequency diagrams, like that. So this is the example how to find out class intervals, frequency distribution, class intervals, frequency and range width of a class for a given set of numbers, So first, the following data represents the ages of 30 students in a statistics class. Construct a frequency distribution that has 5 classes. So this is the example of some example of finding frequency distributions taking some sample data. So construct a frequency distribution that has 5 classes. So the following data represents the ages of 30 students in a statistics class. Construct a frequency distribution that has 5 classes. So we may construct a frequency distribution table by using 5 classes of 30 students ages, considering 30 student ages. So the data is 18, 20, 21, like that. So how to construct a frequency distribution table? So first step is the number of classes is stated in the problem. So here in the problem, in the problem only we may have the number of classes to be taken, and the second step is the minimum data entry is 18 and the maximum data entry is 54. So the range, so in the data the minimum value is 18 and the maximum value is 54. So what is the range? Range is equals to maximum value minus minimum value, that is 36. Divide the range by the number of classes to find the class width. So number of classes is 5. So class width is range by number of classes. Range is equals to maximum value minus minimum value by number of classes, that is 36 by, that is 54 minus the 18, that is 36 by number of classes is 5. So 36 by 5 means 7.2. 7.2. So rounding of this value is 8. So next step is the minimum data entry of 18 may be used for the lower limit of the first class. To find the lower class limits of the remaining classes, add the width to the lower limit. So in this example, the lower limit is the minimum value or lower limit of the value is that is 18 plus width is 8. So we start the class intervals with 18 plus 5, that is 26, plus 8, 34, like this. So that the lower class limits are 18, 26, 34, 42 and 50. Similarly the upper class limits are 25, 35, 41, like that. So what are the upper class limits? Upper class limits means the similarly make a tally mark for each data entry in the appropriate class. The number of tally marks for a class is the frequency for that class. So what is the frequency? Frequency is nothing but the number of data items, which fall under a particular class interval. So what is the frequency of a distribution? What is the frequency of a distribution? The frequency of a data distribution is nothing but it is the number of data items, that the number of total number of data items which are fall under a particular class item. So how to find out a frequency? So after creating class intervals, after finding class intervals or class ranges, we may use we may take one by one data item, that is the number in the sample data, from the sample data, and put a tick mark under which category it is taken from. For example, if a first number is 18, first number is taken, first of all start with some first number, that is 18. So 18 is falls under 18 to 25 class interval, so put a tick mark there. So in that way, count all the numbers from the sample data, and count the total remaining values, or count the total number of values in a particular distribution. So this is the table. The first one is class, that is the class. In the previous slide we may know how to find out the class intervals, that is 18 to 25, 26 to 33, 34 to 41, like that. And we next up tally. In that tally part, we may count take one by one all the numbers of the sample data, and put a tick mark against that particular class interval, and find out the frequency. The total number of tally items is called as a frequency. So what is the frequency? Frequency F means the total number of data items falls under a particular data range, a particular data class range is called as a frequency. So in this example, the classes is taken as 18 to 25. Generally these are taken with ages of a class, and tally and frequency means number of students. So this is the sample diagram, simple example to find out a class interval or a frequency distribution of a sample data. So in this example we may take and after finding out the frequencies of all the data ranges, we may find out the sum. We may find out the sum of the total frequencies. That is 13 plus 8 plus 4 plus 3 plus 2, that is 30. So sigma f, frequency is f, so sigma f is equals to 30. 30 means check that the sum equals the number in the sample space. So sigma f is the total or sum of all the frequencies in the given example. So midpoint, what is the midpoint? Another term is midpoint. So midpoint, how to find out midpoint of a class interval? The midpoint of a class is the sum of the lower and upper limits of the class divided by the midpoint is sometimes called the class mark. So midpoint is equals to maximum value plus minimum value by 2. So class, in the class 1 to 4, frequency of 4, midpoint is equals to 1 plus 4 by 2, that is 2.5. Find the midpoints for ages of students' frequencies. So class 18 to 25, 26 to 33, 34 to 41, 42 to 49, 50 to 57, and frequency and midpoint. So sigma f, sum of the frequencies is sigma f, that is equal to 30. So midpoint is 18 plus 25, that is 43 by 2 is 21.5. 26 plus 33, that is 59 by 2 means 29.5. 34 plus 41, that is 75 means 37.5, like that. So relative frequency, the relative frequency of a class is the portion or a percentage of the data that falls in the class. To find the relative frequency of a class, divide the frequency f by the sample size n. So relative frequency is equals to class frequency by sample size, that is f by n. Relative frequency is equals to class frequency, that is f. F means sum of the all frequencies by sample size, that is n. So class, in the class 1 to 4, frequency f is 4, relative frequency is 0.222. How to find out? So relative frequency is equals to f by n. F is equals to 4, that is relative frequency is class frequency, means the frequency of that class by sample size. Sample size means n. What is the sample size? N means 18. What is the sample size? Means 18. So 18 is equals to 4 by 18 is equals to 0.222. What is 18? 18 is the sample size of the data. Sample size of the data. So relative frequency is equals to frequency by n, that is class frequency f by sample size n. So find the relative frequency for the ages of students class frequency distribution, that is class 18 to 25. Frequency f is 13. Relative frequency is equals to f by n. What is f? Frequency, that is 13 by n. What is n? N is the number of sample size. N is the sample size. So similarly, sigma f is equals to 30, and relative frequency sigma f by n is equals to 1. Sigma f by n is equals to 1. Similarly, cumulative frequency. What is cumulative frequency? The cumulative frequency of a class is the sum of the frequency for that class and all the previous classes. So in this example, class 18 to 25, frequency is f. Cumulative frequency means we sum up all the frequencies starting from the beginning to the next level of frequency or previous level of frequency. So the frequencies are 13, 18, 4, 3, 2. So the cumulative frequencies are 13. 13 plus 8 is 21. 21 plus 4 is 25. 25 plus 3 is 28. 28 plus 2 is 30. So class frequency f and sigma f is equals to 30, and the cumulative frequencies are 13, 21, 25, 28, 30. So total number of students is 30. So total number of students are 30. So frequency histograms. So how to represent the data or information? How to represent the data or information in a graphical way or a graphical pictorial representation? The frequency diagrams or class intervals like that. So a frequency histogram. So frequency histograms. What are frequency histograms and how to draw them? A frequency histogram is a bar graph that represents the frequency distribution of a data set. The horizontal scale is quantitative and measures the data values. The vertical scale measures the frequencies of the class. Consecutive bars must touch. And class boundaries. What are class boundaries? Class boundaries. What are class boundaries? Class boundaries means class boundaries are the numbers. Class boundaries are the numbers that separate the classes without forming gaps between them. The horizontal scale of a histogram can be marked with either the class boundaries or the midpoints. So how to depict or how to draw this frequency histogram diagrams? So class boundaries. So find the class boundaries for the ages of students frequency distribution. So class 18 to 25, 26 to 33 and frequencies. What are class boundaries? The distance from the upper limit of the first class to the lower limit of the second class is 1. Half this distance is 0.5. So what are class boundaries? Next is frequency histogram. So draw a frequency histogram for the ages of students frequency distribution. Use the class boundaries. So here In this diagram there are two axes while taking x-axis and y-axis. X-axis generally contains, so draw a frequency histogram for the ages of students frequency distribution. Use the class boundaries. So in this example, in the x-axis we may use ages, and in the y-axis we may taken as frequency. So this is the example. So frequency is taken as y-axis, that is 0 to, in the starting from 0 we may taken it as 2. So 0, 2, 4, 6 are taken up to 14, and in the x-axis, that is age, that is 18, we may taken it as 18, 0 to 18, 18 plus 18 plus that is 8, 18 plus 8 is 26, like that. So we may draw or depict the pictures of bar graph using that. So frequency polygon. A frequency polygon is a line graph that emphasizes the continuous change in frequencies. So ages of students, in the x-axis we may taken as frequency, that is starting with 0, 0, 2, 4, 6, 8 up to 14, and in the y-axis we may taken as, and in the y-axis we may taken as 0 to 14. So how to draw a frequency histogram? Draw a frequency histogram for the ages of students example. So frequency polygon. A frequency polygon is a line graph that emphasizes the continuous changes in the frequencies. Generally frequency polygon is used to measure the changes in the frequencies, to measure or identify the changes in the frequencies in the given data. So the same examples, generally in frequency polygon we may use a dotted notation, and we may continue all dots with to form the diagram. Next is relative frequency histogram. A relative frequency histogram has the same shape and the same horizontal scale as the corresponding frequency histogram. So relative frequency, that is portion of students and ages of students. Next is cumulative frequency graph. A cumulative frequency graph, or OG, is a line graph that displays the cumulative frequency of each class at its upper class boundary. What is cumulative frequencies? Means the sum of the frequencies of the next are frequencies. Means cumulative means the continuous sum of the frequencies starting from the beginning, adding with the next frequency till to the last frequency. So in this diagram we may take, it is a dot diagram, or it is a dotted graph, and generally in x-axis we may take ages, and y-axis a cumulative frequency is taken as in y-axis, and age range or ages in the x-axis, that is 0, 18, 26, 34, like that. So more graphs and displays. What are the more other type of graphs and displays? So stem and leaf plot. In a stem and leaf plot, each number is separated into a stem. Usually the entries leftmost digit, and a leaf usually the rightmost digit. This is an example of explanatory data analysis. So the following data represents The following data represents the ages of 30 students in a statistics class. Display the data in a stem and leaf plot. So ages of students of 30 students in a statistics class. So how to draw or depict stem and leaf plot diagram. So another type of method graph is a dot plot graph. In a dot plot graph, each data entry is plotted using a point above a horizontal axis. Example, use a dot plot to display the ages of 30 students in the statistics class. So in this diagram, we may simply taken as a single line of ranges of ages with a range with a starting from 0 to maximum value, taking in the steps of class interval, that is 8. So 0 to 15, 15 plus 7 is like that. Pie chart. A pie chart is a circle A pie chart is a circle that is divided into sectors that represent categories. The area of each sector is proportional to the frequency of each category. So what is a pie chart? A pie chart is a circle that is divided into sectors that represent categories. The area of each sector is proportional to the frequency of each category. So accidental deaths in the USA in 2002. This is a simple sample data taken. So accidental deaths in the USA in 2002. Type frequency. So motor vehicles 43,500, falls, poison, throwing, fire, ingestion of food or object to firearms, like that. So how to depict or draw a pie chart? To create a pie chart for the data, find the relative frequency percentage of each category. So in this example, type frequency and a relative frequency. How to find out a relative frequency? What is the relative frequency? What is the formula of relative frequency is so how to find out a relative frequency? What is the formula for finding out relative frequencies? Frequency by n. Frequency by n. Where is f is corresponding class frequency, by n is the number of students or number of items or the number of data items taken. So in this example, here there are we may find a total number of frequencies, total sum of the frequencies, that is small n. Small n is equals to 75,200. Small n, what is the n? N is the number of items. N is the number of items in a frequency diagram or in a class interval, and Relative, what is the formula for find out relative frequency? Is frequency by total number of items, that is f by n. Relative frequency is equals to f by n, where f is the class frequency by n is the total number of items. So in the first class, that is for motor vehicles, relative frequency is 43,500 by 75,200, that is 0.578. So how to depict or how to draw pie chart using relative frequencies. So similarly, next find the central angle. To find the central angle, multiply the relative frequency by 360 degrees. So in this example, type frequency is 43,500, relative frequency is 0.758, and what is angle? Angle is nothing but in a pie chart, how to find out an angle of a particular sector means it is simply multiply the frequency, relative frequency by 360 degrees. So here in the first class, that is motor vehicles, relative frequency is 0.578. So angle is 0.578 into 360 degrees, that is 208 into 2, 208.2 degrees. In the further false category, 0.162 into 360 degrees, that is 58.4. And in the Poisson cases, 0.085 into 360, that is 30.6 degrees. And in the drawing, 0.061 into 360 degrees, that is 22 degrees. So in this case, so again the sum of all the angles of the class intervals, or sum of the total sum of the angles, degrees of the angles of the given class interval should be equals to 360 degrees, that is 208 plus 58 plus 30 plus like that, the sum should be equals to that 360 degrees. So while drawing pie chart, we may use different symbols for different class intervals or different data items. So in this example, motor vehicles classes have 57.8 degrees. Motor vehicle accidents have 57.8, that is the maximum. And then the next is false, that is false category, that is 16.2 degrees. Like that we may depict or draw pie charts.